8 years ago I started my own lab at Harvard Medical School, and when you start a lab there's very little funding and it's very hard to get the first government grant. And what I really appreciate was the grant from FR, and this was an award that allowed me to launch my lab and get it up and running before I had really any significant government funding. But now we're a large lab and very independent, and that's thanks in large part to the FR's help at the very beginning. So at Harvard I run a lab and we're studying genes called longevity genes, and we're studying a particular group of genes called sirtuins, and we believe that these genes could be very beneficial in treating diseases of aging, all the way from cataracts to osteoporosis, cancer, and even Alzheimer's disease. So just in the past few years there have been amazing leaps in the development of new medicines based on the basic biology of aging and the research that's gone on in just a few labs around the world. And these medicines hold the promise of radically changing medicine as we know it, one drug potentially treating and preventing dozens of diseases. And just in the next few years we're going to see that progress and hopefully some new medicines on the market that the consumers can even take and experience the benefits of this research. Over the last few years we've made really great strides in understanding the basic biology of aging, but we still have a long way to go, and there's a lot of discovery we can make. But even with the little that we do know, now the challenge is to translate those discoveries into radical new medicines that can treat broadly very different diseases. So imagine you take a pill to prevent your osteoporosis, but it also prevents and even treats cardiovascular disease and Alzheimer's.